So you see how I've identified the variables? Then we'll just write the equation, and we're looking for V2, so I'm going to leave that as V2, right? Don't put X in there. That could be confusing. In this video, we're going to work a couple problems using the combined gas law. So I'd like to start by identifying what 1 and 2 mean. So we have pressure, volume, and temperature, and we have it under two sets of conditions. So I would say this is condition 1, and then we have condition 2. And what does that mean? Well, let's say we have gas, maybe some gas inside of a balloon, and we make a change to it. Maybe we heat it up, or maybe we smash the balloon or something like that. How does that affect the other variables? That's what this equation is powerful enough to do. So let's look at a problem. Now, this looks like a lot of information, but let me show you how to break it down. First of all, let's read this problem and identify the variables. And so I recognize this as a volume. I'm going to call that volume 1. So I have that volume, and then it goes with this pressure. I'll call that pressure 1. And then we know the temperature of that gas, and so that is T1. But what I'm going to do right now is fix that, because I know I want that in Kelvin. And so 200 degrees Celsius is 473 Kelvin, because remember, we have to be in Kelvin when we use our gas law problem. Now let's go to the second set of conditions. So something happens. We're going to cool it to 20 degrees C, which happens to be 293 Kelvin, and we know a new pressure, right? And what we're looking for is the new volume. So what is the volume that goes with those conditions? So you see how I've identified the variables? Then we'll just write the equation. As written, P1 V1 over T1 equals P2 V2 over T2. All right, now what we need to do is insert these numbers, but I do notice that my pressures don't match. What bothers me is my pressure at 1 is in millimeters of mercury. So I want to convert that quickly into atmospheres. So 1 atmosphere is 760 millimeters of mercury, and so that new pressure is 0.95 atmospheres. So you'll see in a second why I want to do that. All right, so pressure 1 is 0.95 atmospheres, and then volume 1 is 5.8 liters, and I'll multiply here so it won't confuse you. Okay, and then on the bottom I've got 473 Kelvin, and then on the other side my second pressure, 3 atmospheres. See how easy this is when we label things up? And we're looking for V2, so I'm going to leave that as V2, right? Don't put X in there. That could be confusing. And then my second temperature was 293 Kelvin. Now look what happens to these units. This is what's really cool about this. I've noticed that atmospheres cancel on both sides. That's why I match those pressure units. And then degrees Kelvin, or not degrees, just Kelvin, cancels on both sides. So now I'm left with a bunch of numbers and one unit, and it happens to be liters. And so I'll rearrange this equation to solve for volume, and we'll use 2 sig figs, 1.1, and the unit comes out to be liters. Now why is it liters? Because liters went into this equation. Okay, so you can see the importance of writing your units. Let's do one more problem. So this time we have gas under a certain pressure. I'll call this P1 in kilopascals. And I've got temperature 1, but remember I want to fix that. I'll add 273 to that and get 297 Kelvin. Okay, so let's make sure we have that established. To what temperature would I heat it? In other words, what is T2? And I like to write T2 equals question mark. That shows me what variable I'm looking for. And then this is the second pressure. Now in this case, my pressure units match. And so I'm going to write my equation. P1 V1 over T1 is P2 V2 over T2. Write it every time, okay? Now you're looking at this problem and you say, well, where is the volume? Well, in this case, the volume is constant. How do I know? It's a rigid tank. Volume is not mentioned. So whatever that volume is it is the same on both sides. So what I will do is cancel that volume out of my equation. Now I'm ready to add in my variables as numbers. Okay, so I have 95 kilopascals, and on the bottom 297 Kelvin. On the top is my, oops, sorry, I do know P2. So I've got 260 kilopascals, and then T2 is on the bottom. Now my units cancel nicely. I have kilopascals, and my temperature is in Kelvin, and so T2 is going to be equal to 260 times 297 Kelvin over 95, and that is 810 Kelvin. So that is, there are two examples of using the combined gas law. I think the secret is identifying those variables before you go to that equation.